Actually, David, thanks for a great introduction. No one called me a great NLP engineer before, so that's a good start. So basically, it's about a couple of things we try to do in Informatica, and overall there is no magic. There is nothing that just works and gives you data for free, unfortunately. Something works, something doesn't. It's all very kind of initial in terms of the text data. So you did right saying that, say, on images, it's fine. On images, it works. Everyone does it and everything is okay. But in text, it's not as simple. So this one is basically just about what we learned when we tried doing it, what worked, what didn't, and what didn't probably will be more than what did. But that's just it. And I guess Informatica is probably not one of the the very well-known players in the ML field, and mostly the products are for managing data for, like, say, if you're the size of Amazon or Bank of Ireland or something huge, and you have all kinds of data sources and tables and files, whatever. You need some kind of tools to keep this stuff organized in a way, know what's where, what's linked, what's derived from what, and all this kind of thing. So it's not really kind of consumer products, but still there is a big scope for simplifying interfaces. So say, for instance, you can, there is a very complicated tool where you can build a so-called data quality rule. So just a rule saying that a certain column can't be null, or a certain column should be greater than 0, or something like this. So you can do it in a very complex interface, or you can invent some kind of natural language interface where you just type in what you want. It just figures out what you want and constructs the thing for you. That's just one of the examples. I'll be mostly talking about the context of supervised learning. So, like, if you read anything on data augmentation, there'll be domains like adversarial learning and all kinds of other fascinating things. But here it's just supervised learning. So the main assumption is that you have more data and you end up with a better model. We all know it's not always the case, but that's the main kind of premise here. So again, there are ways to get new data, more data we all know about. Like, say, in some domains, you can just crawl the web. You want movie reviews, fine, go on IMDb, crawl more, and it all work. In some domains, you can do it on Amazon Mechanical Turk. Like, say, if it's translation, you can, and some people actually did at some stage, get translations from some kind of peculiar languages to other peculiar languages and things. Again, sometimes in big companies, it's possible just to ask someone to generate data for you if it's something very niche and very peculiar. Again, it doesn't really work all the time. And especially in this kind of area, that's why I thought this topic might be interesting for the chatbot community. When we're doing something related to chatbots or natural language interfaces, we often are the first to do some task. So it's not that we can go on the web and just get gigabytes of data. We have to do something ourselves, and it's usually a problem. And here, the point, again, it's the same example I mentioned in the intro. It's basically just converting natural language, like here in sentence examples, intro, a particular proprietary language. It's not really interesting. But it's basically just natural language to text. So it's kind of similar in a way, like if you heard of some work that I think Salesforce are doing when they're converting natural language to SQL queries. So those are not really SQL queries. It's slightly simpler, but still, that's the idea. And what we try to do here, we, as the first step in the pipeline that does this thing, we needed to classify a sentence into one of 6 cases. Like, say, okay, is it a null check? Is it a not null check? Is it a greater than equality? Is it whatever, this kind of stuff. It's kind of intent recognition, use case recognition, this kind of area. So what we tried to do is, okay, we need to get the data. We can't use the customer's data, obviously, just all kinds of boring legal reasons. So what we tried to do is, okay, let's go on Amazon Mechanical Turk first. Let's see how much we can get and take it from there, basically. And it's like, it's obviously, it wouldn't have been about data augmentation if we had got enough on Mechanical Turk. So you can guess that it was a small data set and we needed to do something else more. And the idea was, okay, can we do it? And we started doing it manually. We started just looking at sentences and saying, okay, this one, how can it be rephrased and this kind of stuff. But then it got a bit boring, and as people say, every good software engineer is a lazy software engineer. So I'm not sure if I'm good, but I'm certainly lazy in this way. So okay, is there a way to do it in automatic way and just keep it simple? So for images, it's easy and kind of mainstream. So it's like on Kaggle, there are lots of data challenges about brains and tumors and all these kind of things. So what people usually do, they just take the input image and they rotate, flip it, whatever. But it's still an image of a brain, and it's still an image of a brain with a tumor. So it doesn't become an image of a heart or a healthy brain or whatever. And in TensorFlow 2, I'm sure you guys seen it so in some context. There are so-called data generators. It's just a utility that basically sucks data up from somewhere, from a file or database. And you can do even more if it's image data. You can set up certain parameters, and you can just say, for instance, there is something called vertical flip or rescale or something like this. So this function, this generator, will give you more data than you actually load it into it, basically. So very convenient, out of the box, just works fine. And it's mainstream in computer vision. In NLP, it's slightly different. And there is actually a nice quote here that I'd like to give. So in natural languages, it's very difficult to obtain universal rules. So you can try hard, but you won't be able to come up with something that works for anything you might think of, which assure the quality of the produced data. So it kind of is a polite way of saying, well, even if you get universal rules, then you won't end up with very high quality data. So a bit pessimistic, but we thought, well, come on, it was 2018. So like in 2 years, a lot can change. So maybe we can do something. And the intuition is still exactly the same. So you just take a sentence, like you take an image, you change it a little bit, but it still should be the same thing. So if it's a positive movie review, it mustn't become a negative movie review, or otherwise, what's the point? So there are some things that there are probably multiple ways how you categorize them and stuff, but they're kind of big groups. So the first group is something that's often called generative approaches. So you take a huge deep network, you train it on a huge corpus, and it starts generating you sentences similar to the ones from the corpus. So it's kind of, in NLP courses online, you often can get a Shakespeare kind of generator based on some easy, like simple frequencies and things. So it, after 5 minutes of training, starts giving you something that sort of looks like Shakespeare a little bit. And with deep learning, this kind of models got a bit more advanced, smarter, and they sort of work and they sort of are fun. But if you want to use them for something real, like actually getting similar data to what you have, not just, for laughs, it often generates not really valid sentences. This is true of 2016 and 2017. So with the appearance of BERT 3, for instance, it might change, but that's what people think about it right now. Another one quite popular is random permutation. So you just take a sentence and you just do some kind of random damage to it. So for instance, if it was x is lower than 0, one of the kinds of that is just to drop a random token. You can certainly see that it can break, actually, and it can generate you something that doesn't mean the same thing at all. But overall, it sort of works, so it's good enough for people. Another one is just swapping true tokens around. So you end up with kind of master Yoda speech more than often, but maybe it's fine, maybe it's all right. There's also back translation, which is kind of a funny one. Intuition is very simple. You take something in one language, you translate it into a different language, and then you translate it back to English. Looks like, say, in this example, say lower becomes less, so we're all happy it all works. But say if you try to do the same thing, actually I tried to do it with Google Translate while preparing for this talk. And no matter what you do, you just end up with the same thing. It's probably because they work with some kind of embedding of a sentence which is independent of any language. Might be, I don't know, experts on machine translation might maybe tell us more about it. But just no matter what, I tried all kinds of languages, even Latvian, which is not the most common language on this planet. Still exactly the same thing. But sometimes if you're using something different, you can get it and it's fine, but you need to find the models, you need to find something that basically gives you like intro language and back in both directions, which sometimes is a bit tricky. So certainly can work, but a bit fiddly, and with technical language, you won't get too far. And also for one sentence, you can only get one other sentence usually. So usable, but again, depends on the domain. Just a reference if you're curious about reading a bit more about it. And the most common one, as according to the quotation a couple of slides ago, is actually synonyms. And so you just take a word somewhere in the sentence and you replace it with a synonym, even say from WordNet or something really simple. You don't have to do anything like deep learning synonym something. WordNet works reasonably all right in theory. In practice it doesn't, but that's the idea. So these are the ways people basically do things. And we looked at it and thought, we don't want generative approaches because it will just screw up our text. Random permutation, yeah, maybe, let's try that. Back translation, no, just finding the models and finding the APIs that won't give you all your data to someone else like Google. We just couldn't do it. So we thought, right, don't want to do this. So random permutation, synonyms, something like this. And then we started to do a bit more reading and just, again, when you're prototyping, you need to steal someone else's code to see how it works, if it works at all. And we got quite lucky here because there is an approach. Okay, yeah, sorry. That's the data set we gathered initially on Mechanical Turk. So 6 different classes. We showed to people the expression example and said, hey, give us 4 rephrasings of this particular expression. So I ended up with a large number of different ways of talking about these things. So say, for instance, length, someone might say X must be 10 characters. Someone will say X must be 10 characters long. Sometimes someone might say X must be longer than 10 or whatever, all kinds of things really. And we found an approach called EDA, which is called Easy Data Augmentation. And there is actually a Python code that's pretty much reusable. And it has a parameter. So you tell the approach how many sentences you want per source sentence. So you feed one sentence in, how many do you want to generate? And there are parameters that determine the proportion between 4 different kinds. So there is a synonym replacement, a sad superior human, whatever, sad becomes lamentable, and so on. Random insertion, again, that's random permutation kind of thing. It just finds a word in a sentence, finds a synonym for it, and just throws it into the sentence in a random place. There is also random swap, just swaps true tokens, and there is random deletion, which just deletes a token. So like anyone who looks at it and who has a somewhat critical mind can say, well, actually this stuff can break your sentence. So it's not that you end up with something perfect or even good sometimes. But the results are quite promising. And as we know, classifiers can sometimes sort of negate the effect of noise and still work fine. So we thought, yeah, we don't have to write code. We just get this, load the data, see what happens. That was the idea. We did this experiment, but basically tried something different. And in our case, there are six classes, and they're sort of opposable classes. So, for instance, if something is equal to 0, then the opposite to it is something is not equal to 0. And the way we can use it is if you imagine a very simple kind of degenerate corpus with reviews where there are just true reviews. Synonyms can be used quite successfully for that. You can just use EDA and good becomes great and nice, stupid becomes dim and dumb, for instance. So end up with this kind of corpus, and it seems all right, but actually all your negative reviews are still very short reviews, and all your positive reviews are much longer. So if you try to use, say, deep learning on something like this, it might just learn the length, not the actual words or something crazy like this. So what you can do instead, you can use antonyms. So good becomes bad, stupid becomes clever. And now, obviously, you can basically you have sort of a cross-pollination of these two classes, which is much potentially can be beneficial for what you're doing. But again, only in the cases where you have opposable classes, and that's what we basically had, luckily for us. So there are actually ways that people try to use this intuition. And there are well, Banso in particular is a big name in natural language processing. So in one of their papers, they tried to do it in an automated way. So a synonym kind of makes sense, but they also did add negation, which means you go through the sentence, you find a verb, any verb, and if it's not negated, you add the negation and return the sentence. That's what it's called, add negation. They also did something they called antonym, which is, again, you go through words left to right, you check all words. Again, there is a small discrepancy between what they show in the paper and what's actually in the code. But basically, you just go through the words and take all synsets from WordNet that this word belongs to and get all antonyms from them and then select a random antonym. So essentially, it's a long-winded way of saying that we just replace it with an antonym from WordNet chosen randomly. So that's it, nothing else. Pretty simple. And say, if you have something like x can be bigger than 0, we go from left to right, we find can, not is not there, we can see it in dependency graph easily. We just throw this not in, fine. This is our negated sentence, completely like reversed meaning. With antonym, something like this, x can be negative, so we find negative, we replace it with an antonym positive, should be easy enough. But in reality, it doesn't work that well. And say, for instance, you can have x can be negative. You want x can be positive, obviously. But what actually happens, the algorithm goes through it, it sees can, but actually can is also a synonym for fire. It's just there in a different synset, it means fire. So it takes that synset, takes the antonym, and replaces can with higher, x higher be positive. Just like, come on, it's better not to do any augmentation than do augmentation like this. And it gets better, like say x must be lower than 0. You want higher, it doesn't preserve the comparative, which is probably all right, but still kind of why would they do it this way? It's easy to tweak it. But the favorite one I saw was this one, x is no bigger than 2. And the first word with an antonym is no, which gets replaced by yes. And that's just like, no, it's just not going to work. So we didn't really have huge expectations, right, for those approaches. And what we tried to do is we took, in addition to EDA is completely different. So we can do EDA, we can use it, but this one is just kind of taking the next step. And I'll show you the numbers and everything a bit later. But this one is just different. So EDA works based on synonyms, it just rephrases things. This one works on antonyms, which helps with our opposable classes. So we did something that we call main verb inversion, which is similar. So we take the verb, but we make sure it's the main verb in the sentence. We add the negation as Neo and Banso did, but we also remove the negation if it's there. A really trivial, simple trick, but why not? With antonyms, we decided to do it a bit better. We thought we are only going to attempt, like there are two ways. One of them is just to generate as many additional sentences as you want without caring about quality, or care about quality and end up with a much smaller number of sentences. And we thought, yeah, we want the second way. So we only did it if there is one adjective or adverb in the sentence. Again, you look at the dependency graph and it's all very easy. Should be connected to the root. Again, it's not a very important detail, just if anyone is curious. And then replace it with an antonym, preserving comparative superlative. So we still can end up with a wrong synth set. That's still possible. But at least we're not doing something crazy like replacing no with yes. So maybe it works, maybe it doesn't, we don't know, but thought at least it's a good first step. So experiments. We did a 6-class classification. So basically we needed to determine the intent behind whatever the user puts in. And we used the well-known CNN by Yoon Kim. Again, you guys probably have used it many times, nothing unusual here, just a CNN with word embeddings, very standard. We did 2 experiments. One of them was, okay, is there any point in doing all these clever reversal-based tricks at all? Or maybe it doesn't help at all. And the second one was, well, okay, if your reversal-based stuff works, then maybe you can just download that EDA code and achieve similar results with just something out of the box. So you just reinvented the wheel, and what's the point? So, sorry, that's an academic-looking table, but here, basically, what we try to do artificial undersampling. So it's kind of intuitive that if you have a very small data set, if you do augmentation, it helps you more than if your data set is huge and rich. So ours wasn't huge and rich, really, but still we thought we'll just imitate all kinds of conditions and see what happens. Different augmentations give you different additional sentences. Again, makes sense. Their group, like there are antonym-based approaches, Neo and Banso's and ours, and same for verb negation. So that's just the baseline. That's just the macro F1 numbers. They're not hugely high, but whatever, it's the baseline. And with antonym, what we saw is that when you look at a full data set, 75 to 100%, this antonym approach by Neo and Banso that replaced yes by no actually is statistically significantly worse than the baseline in these 2 cases. That's why there is this triangle kind of facing down. It doesn't really have any effect on 50%, and it's actually quite a bit better on on the very small data set, statistically significantly better. Our approach was it didn't damage, at least. It didn't really improve much except this 25% case. And it actually was worse than this crazy Neo and Bansos approach. So again, it's not very consistent. It's not something that we can use and recommend. But with negation, it was a bit better. Neo and Banso's negation was better in 2 scenarios and worse in the full data set, while ours was actually better than the baseline in all 4, and actually significantly better than add negation by Neo Banso as well. So it's like, again, loads of numbers, but basically the idea is that if you try to do something clever with antonyms, good luck. It might not be as simple as it seems. With negation, you can do, if you just think for a moment and just do a trivial change to Neo and Banso, they removed negation, we added negation. Sorry, I did that the other way around. They added negation, but we added removal of negation. With this kind of simple trick, you can get quite a good boost in performance, basically. That's the idea here. So, David, do I have like 5 minutes, or I'm probably running very late at this stage?
No, I'm finding it fascinating. So I'd like you to continue if, unless Emer is in some sort of hurry, but if she's okay, we'll keep going.
Oh, no, go ahead. Fire ahead. No problem.
Great. Okay. If everyone's happy, then yep. Great.
Cool. 5 minutes here. Sorry, guys.
No, it's fascinating.
Cool. So basically, the second experiment was, okay, so here you could say that antronomy-based approaches are fine. You can use them. You're getting a bit of a boost. And if you use our approach, it's better than whatever is there. But again, some critically minded people can say, well, okay, so you have your training and your test split. You use EDA, for instance. And what if this kind of condition, when you use EDA, actually is as good or even better as your crazy magic with antonyms and verb negation? So it's, again, so we used EDA, we used reversal-based, and how do you compare these two? What's the fair comparison? So one of the ideas is that, okay, you have this augmented train, and that's your EDA, that's your antonym based, and you can just compare it to the same thing without this antonym based. But when you think about it, it's actually a bad idea, and because in the second scenario, you're just working on a small data set, and some reviewer or expert will come by and say, hey, you know, actually you can't compare them because the sizes are different, so given an unfair advantage to it. So what we tried to do, we did a training split. We used EDA, but we used the EDA that gives us more instances so that we end up with the data sets of the same size. Just to be fair, you know. So here's what happens here. We have the baseline EDA, 70%, 51. So this one was around 27 in 27 previously. This 70 was, sorry, I don't remember, was 56. So we are going quite a bit higher than the baseline with no augmentation if we use EDA, which is actually good news. So it's very simple code. You get it, you use it, it works, recommend it, despite all the cases when it actually breaks text. It does, but come on, it seems fine. So a more important thing, more interesting thing here is we dropped antonyms altogether because they didn't seem to work in the previous setup. But here, add negation on top of EDA doesn't seem to work very well. So same numbers, no point. If we use our approach, then there is a little bit of a boost. So say 68 to 77 to 72, it's not earth-shattering, but still it was significantly different. So there is something there. And it's very simple. So like if there are free 2 percentage points on macro of 1, why not? Might as well take them, sort of attitude. So again, what we learned here was that EDA is easy to use, it actually works, and it can give a decent boost. And yeah, it produces junk, but like it kind of negates, and it's all fine. If you use antonyms, and actually there is a feel that it would apply to anything that's very kind of application specific. It works in, so antonym based here, it's not actually phrased very well, but here I mean negation as well. So it's basically whatever we did with negation and antonyms both. So it's, in our case, it was very application specific because we looked at the training points we had and we just thought that this might work. Minor boost works, but say if you try to do the same with a movie review, and if anyone is interested, I could show how it works or how it doesn't work is a better explanation. But that's the way it works. So it's just sort of we're coming back to the quotation which says that it's not universal whatever you do, and it's not high quality whatever you do. So unfortunately, we just covered the same thing here as well. And textual data augmentation, it's worth trying, right? It's nothing huge. You might as well try and see if it doesn't work, it's fine. But when we try talking to people and presenting at conferences and things, we often got a remark that, you know what, actually, if you're using more advanced models, if you're not using just CNN from 2014, but if you're using BERT, all these kind of tricks in augmentation, no matter what you do, they don't work. So there's a question mark because I don't have a reference for it. I don't have results for it. But too many people told us exactly the same thing. If you're using BERT, just forget about it. Augmentation doesn't seem to work. So I thought it's worth just communicating this one as well. So a bit of shameless self-advertisement, but basically if you're interested in more details and more references, that's probably the most interesting. You can just Google this one and find out more about it. Unfortunately, there's no silver bullet, there's no magic, but that's the way, unfortunately. So I'd be very fascinated to learn if you guys did anything like this, or maybe someone was more successful than us. But that's basically me. Thanks very much for having me. Thanks very much for your attention.
That was brilliant. Thank you very much. No, it was fascinating because, yeah, you came across some of the similar conclusions as I've seen before, that certain kinds of augmentation don't work, and the popular ones are just dreadful. These sort of will stick synonyms into random sentences in random places, and I never thought it worked. One thing is, I think one or two people might have an 8 o'clock cutoff. So because of that, I'd like maybe if we can get Emer to talk now and then we do the questions at the end, if that suits people. Is that okay? Just in case anyone has to disappear.
Sure.
Oh, someone's got a message. Let me see what they said. Yeah, great presentation. Yeah, so we'll tell you what, will I hand over control to Emer?
Okay, go ahead.
Yeah, we'll get her talk, and then actually, because Alexey's here, he should be able to answer questions even by now how do I? Oh, sorry, you've got control, Alexey. Can you hand it over to Emer or back to me?
Yeah. How do?
Just go over my name and make host.
Cool. Yeah.
Or
Perfect.
tag.
Make host. Yeah, cool. Yeah. Sorry, I'm not a power user of Zoom.
That's a good sign.
You done it.
It's like being really good at Excel is a bad sign. All right. So next is actually Emer's probably Adapt Center in Trinity and startup and NGOs. And her last talk here was
all sorts.
Her last talk was brilliant. So I'm really looking forward to this one.
I don't know about it this time. Now, first of all, we have the comedy of the screen sharing. Can everybody see my slides rather than?
At the moment it's you, but we could see your slides a second ago. I think maybe when
okay, I'm just gonna go to the right desktop and share the computer sign, and then we should be okay. Okay, so are you seeing the slides?
Yep, slides now.
Brilliant.
I'm going to mute myself. Alexey, I think you're still not muted, but it doesn't really matter for you. Okay.
Okie doke. Right, so I have about 20 minutes. Right, let me just check my watch because I do tend to ramble.
Oh no, you have plenty of time. Don't let us rush you. You have plenty of time.
Oh, yeah. Anyway, so I'm going to talk about dialogue systems in applications, generally education, a little bit about health, and some comments about the ethics. Now, this is kind of a distillation of 2 talks I gave last week, but basically, what you see on the left is I've been going to conferences in this area for 12 years now. And they used to always begin with a reference to HAL. And then Her came along and Robot Frank. And sometimes you get the kind of the cool guy who talk about Blade Runner and on and on and on. And so we used to play this kind of bot bingo during talks, you know, because we were waiting for it to come up. And this is actually this is the impetus behind natural language interfaces, and particularly spoken dialogue interfaces are the various names. And it's also the source of a lot of the problems. So the dream has always been people wanted to talk naturally with systems. And once you start talking naturally with the system, there's a thing that happens that what was an interface in your mind becomes an agent. And when you add voice, you really start to think of this, not consciously, but at some subconscious level, you think you're talking to a person and you expect human-like behavior. And more importantly, you expect human-like ability from the system. And this is the source of an awful lot of heartache for designers of conversational systems, and also danger. I mean, there was a great thing, I think David retweeted it today about GP3 is not doing too well on the medical chatbot field, you know, absolutely no surprise to anybody, but there you go. So I'm going to very quickly go through sort of a Dialog 101, because I'm not sure of the audience and what people are familiar with or not, and then run through some Dialog systems, show some examples, talk about their use in education primarily, talk a little bit about chatbots, talk a little bit about other systems which have been used in education and health. Maybe if we've time, I don't think we will, but I do want to flag the NGO that I've recently started because I want donors. Okay, so let's go. So now this isn't going to work. Okay, so Dialog one, like, I mean, we all know, I mean, if you're here about chatbots, you know this, that humans do an awful lot of things through spoken interaction, but interestingly, they also do a lot of things not through spoken interaction, particularly formal. You know, practically all of the original Dialog system experiments were about travel. So even if you start now, I think if you were to go and start playing around with Lex, it probably still is booking a plane or booking a hotel. Now, the reason for this was very simple. There was a data set from ATIS at the time, I think, you know, which had tracks of text conversations about booking planes at the time. So that's actually a huge problem all through the whole field, is this kind of warping by data. You have some data, it's the only data you have, and as the models get more sophisticated, you need more data. So you're seeing all sorts of chatbots trained on things like Twitter and Reddit, which actually aren't conversation and definitely aren't the kind of conversation you probably want, leading to the joys of things like Tay from Microsoft becoming a Nazi or whatever happened. The next thing is that utterances do things. The whole concept behind any sort of natural language interface is that when you talk in a transaction, it's not just the words you say, it's the meaning. So if I was to say, for example, geez, it's a bit warm in here, I'd probably be expecting someone to open a window. It could be very close to just saying, will you open that window? And this is where a lot of natural language understanding falls down, because it's still a lot at the level of understanding the words, but not the say more abstract meaning. For example, irony, etc. There was a comedian in Galway yesterday got pulled from Facebook for hate speech because the algorithms cannot recognize nuance. They can throw some sort of sentiment analysis on and say, oh God, he said something, but they don't recognize the fact that he's saying it sarcastically. So this is happening more and more. Now, these acts must be understood by the person who's talking to them. And so you get this conversation where it's like a game. The system or the interlocutors, the two people talking, make moves which build up an information state, which changes through the conversation until the goals of the conversation are met, or we've passed the time happily and now the buses come or whatever. So mostly conversations have been seen as a series of what are called adjacency pairs, which form sequences. So the classic is, do you have a flight to Portland tomorrow? Yes, I have one at 4 and another at 9. The simple case. But what about, oh, there's a bit of ambiguity. Do you have a flight to Portland tomorrow? Is that Portland, Maine or Portland, Oregon? It's Oregon. Okay, I have one at 4 and another at 9. So that there's an embedded little piece of disambiguation. Now, what's really important when you're talking about chatbots in particular is that a lot of chatbots, and this includes right up to Google, etc., do not go further than this two-step adjacency pair, because they're based on command and control. They're based on you say something, the machine fulfills the request. And there may be a little bit of disambiguation in the middle. But many chatbots are not like that. Like, you know, anybody here is probably designing stuff a lot better than that. Anyway, so a generic dialogue system of any description, the user says something. The speech recognition, if you're using speech, recognizes it as something. So you've got some ambiguity there. Then the language understanding recognizes it as something which the dialogue manager or the system which has some semantics for the system which can be used. Then the system, be it stochastic or be it rule-based, decides what to do with it and throws out a response, which can then be dressed up in response generation, in natural language generation. Now, and then thrown out as text, which then gets synthesized as speech. Now, as machine learning has gotten better and better, these three stages, understanding, management, and response generation, the dream is to create end-to-end systems, which go from here up, well, not from there, from here, which go from here right through to here in one fell swoop in a black box. That's successful depending on what you want to do. It can be successful or not. We won't worry about that. Okay, so when we look at what these systems have been, and I've just raced through this, you get ELIZA, which most people remember as being Weizenbaum, secretary, finding it more compelling than talking to a real person. And then he realized, oh, this is terrible, the machines are coming. Because he did something very clever. He created a chatbot based on a particular kind of therapy, which is essentially reflecting back what you say. So it was quite easy to create this. You also started to see command and control, in other words, voice commands for systems like turning on and off the lights. Then we came to James Allen in the early 90s, who realized that the dream of having systems that could basically talk about everything to people was very, very far-fetched. And in other words, a multi-domain chatbot was our natural language interface was really out of bounds at that stage. So from then on, the people concentrated on creating task-based or practical dialogues. So for example, they concentrated on the infamous booking systems. Then you went into IVR with all of those systems where you rang up the bank and a sort of a weird voice answered you and got your numbers, etc. And academically, people were moving towards using AI planning, for example, beliefs, desires, and intents, and information state update ideas, and creating ever more sophisticated skins for these systems. So you started to get more embodiment where the systems would look, they'd have avatars or indeed be embedded in a robot. They'd start to try and understand not only the speech or the text, but also use cameras to pull in a visual stream, and you start to get multimodal systems which would recognize body language, gesture, etc., etc. And then, of course, in the late 2000s, there was a slight little switch where there was interest grew in machine learning in dialogue systems. And at the time, the first piece of interest was actually machine learning in the management of the systems. But around 2012 and earlier, in fact, natural language understanding improved dramatically with larger models. Like there was a dramatic bump in how well a system could get that semantic information out of input from a user and ascribe that or map that to what should be done next. In other words, your dialogue management became essentially a sequence-to-sequence model of some description. Now, this was around the same time as Siri and Alexa started to appear. And now Siri, Alexa, etc. were essentially, and still are, a combination of voice search and command and control. They're not exactly complex dialogues. And then in 2015, a lot of people realized that if you could use something, if you could put a bot basically into a messenger app, you had managed to circumvent having to have an application on a desktop. You cut all of that out and you have direct access to your user, or more commonly customer, because you were now a contact rather than an app. And the app was now in the messaging stream rather than on the screen of the phone or on the desktop. So that's the history, which I've taken far too long with. Okay, so let's go on to using natural language interface in education. This has been going on for a long time. And again, the advantages are that idea of if you're talking to something in a sort of a conversational mode, interestingly, users will perceive the system, as I said, as an agent or a relational agent. And because of this, interesting things start to happen. Because of that agency, it becomes more engaging for the user. But it also, because there are very interesting things happen. For example, there was a lot of research on, for example, if you have a system that, you know, takes notes as somebody is leaving hospital and gets them to fill in a form with you, which is a healthcare rather than education, basically they'd find that people would prefer the system to a human simply because the system is infinitely patient. It will constantly go back and back. It won't embarrass you in front of everyone else. You don't have to be the guy in the class who's not answering the question because you don't really understand, but you don't want to bother everyone else. So you get this kind of home tutoring idea was very, very useful. The other thing was they discovered, for example, if you take an exercise system and get people to, chat to, talk about what the exercise they've done, you get much higher retention of users. Now, interestingly, if it's chat, and particularly if it's voice, they don't tend to be quite as honest as when they're filling in a form, but you will retain your users. So it's whatever floats your boat. Now, so these systems were very, very common in STEM subjects because it's a lot easier to have a dialogue system, particularly a rule-based one, where the answer is 4 than when the answer is something abstract that involves opinion, etc. But we do have lots and lots of work now on essay marking, dialogue for practicing language, etc., etc. So computer-aided language learning, computer-aided pronunciation training, and coaching are the main uses. Assessment is the money spinner in a lot of this. So a lot of the bigger companies are going after ways of replacing human examiners, particularly for oral exams, in marking verbal performance on various kinds of interviews and tests. So that's kind of what they're supposed to be. Now, chatbots, which came along around 2015, have been used in education, and you get a lot of talk about this. Obviously, because the app is in the channel, they can use text, speech, rich media. You can show videos. You can put in a little bit. You can put in access to social media, etc., etc. They're great for kind of mediating material, for working through, showing a video, asking a few questions, moving on. They're great for quizzes and instant feedback. Obviously, all chatbots are really good if you already have a question answer table or an FAQ. They'll make it engaging. They'll make it something that has a sort of a conversational aspect. And this is great if you're teaching something like history. You can ask and answer questions. They're great for onboarding as a training mechanism. There's lots and lots of no-code platforms, so they're quick to put up. And there are also a couple of really nice things. There's a really nice one, which I can't remember right now, by Vlad Serban, which actually teaches AI through a natural language interface, through a very sophisticated, a really sophisticated sort of end-to-end chatbot. I'll find the reference because it's a very good thing. But the problem is that because they're so easy to put together, and we're kind of at a stage where, I'd like to do a course, especially during COVID, like as in I'd like to write a course and sell it. So I'm going to get myself a chatbot platform and do it. So I looked up, now this was last week because it was before the other talk, the top chatbot education piece in a list of top chatbots, and came upon this. And when I went to Facebook Messenger, it's gone. You can't log on. So you get a lot of, I'm not exactly vaporware, but outside of the more reputable companies, you get a lot of this kind of thing, shall we say, which tends to pull down the whole field. Now, in terms of chatbots or any sort of education, ASR / spoken language understanding / natural language understanding is always a problem. So I'm seeing two things happening with chatbots. First of all, you've got this kind of, well, I'm thirsty, but maybe an espresso would be too much. I want to sleep tonight, so maybe something with milk, maybe a latte. No, cappuccino would be better. And could I make that a large one? Oh, and I really like the new uniform, which is perfectly plausible in Starbucks. And what the hell is wrong with the button in a situation like this? And that's where the chatbots are going. They're starting to see essentially kind of mini websites within the bot with lots of user interaction through buttons, because the whole thing is to reduce the ambiguities introduced by free user input. So you're kind of essentially just working away towards a little website. On the other hand, the truly interactive chatbots are still coming along. And interestingly, in my view, they're kind of coming back to dialogue system research, where they kind of came out and reinvented the wheel for a little bit, and now they're coming back in. So I'm nearly done. I've somehow managed to turn off all of. Okay, so I think we talked about that. There's a lot of machine learning being used by various companies, particularly around language learning. Now, I'm going to show you a couple of examples of other systems which are not chatbots. I don't know if you've seen any of these before. I'm really sorry. I'm just going to play you a little bit of each. This is a system from California, and the idea is that she's a virtual therapist, and you talk to her and she senses your mood and brings you through it. They're essentially built for triage for the US Army generally. So just see how it does.
I'm
from Los Angeles.
Oh, I'm from LA myself. When was the last time you felt really happy?
When was the last time?
So basically, this is built on a lot of machine learning. There's a module which is, taking in what it sees. There'll be a module for body language. The system is not programmed to gesture. It's generated. And it's hooked to what the guy is doing. You'll see that there's the wireframe on his face, so it can check his eye gaze direction if the gaze is down, plus it's looking at the pitch of his voice. So if you get this kind of slow and flattened pitch, plus lowered eye gaze, it can go, yeah, there may be depression there, et cetera, et cetera. So they're being used in these kind of diagnostic ways. And the same lab actually use this for lots of things because they have tons of money from the American Army. So they use it for sort of VR training, battlefield training. Nice uses in education, for example.
My name is Pinchas Guter. I will answer any questions you might have for me.
How old were you when the war ended?
I was between the ages of 13 and 14 when the war ended in 1945.
Do you remember any songs from your youth?
This is a lullaby that my mother used to sing to me, and I still remember it. It's in Polish. Jadą dzieci, jadą drogą, siostrzyczka I brat, I nawidzić się nie mogą, jaki.
So that's really nice. They use the same kind of system for training on sexual harassment in the army, where the system, which is, it can be, I've talked to every one of these systems either live in a situation like this or on a laptop, and they're very, very convincing. So in this case, the soldier is modeled on a survivor of sexual harassment in the army. And it's an awareness raising educational exercise where the students here can ask any question they like and the system answers. So all of those are very nice. Now, I just have one question. None of those were YouTube clips, and I wonder why. The reason is that all of those systems are pre-2013. They were built 2010, 2011, 2014 maximum. And the problem is this, that at the moment, in academia particularly, when I review papers for conferences, I see some very simplistic work. Now, not the kind of thing Alexey is doing, not the machine learning work, the actual dialogue work tends to be quite naive. And the reason is that any good student will go and do a literature search, they'll write in chatbot, and they'll look at work since 2017, 2018. They won't even come across those systems. They don't see them. Now, ICT, who made those systems, couldn't give a damn because they're fully funded by DARPA. They're never going to be going commercial, but some of their people are. So I think that what I'd like to say is that the not so good chatbots have taken up a lot of the oxygen in the whole field. There may be a backlash coming in some ways. I'm seeing more of this kind of, oh, those AIs aren't so great. And those AIs aren't so great if they're not well designed. And the main problem with a lot of those AIs is bad data. It's nothing to do with the engineering. And then chatbots are very, very useful in an awful lot of situations. And there is a lot of scope for more sophisticated systems to come back online in the future, hopefully. And I don't think we need to go into this. This is just I do a lot of research on the actual shape of conversation in order to build systems which are more, I mean, the whole conceit again of using voice in particular is it needs to be like human talk, because we're built to hear talk, but we're also unable to understand anything really that deviates too far from human type conversation, where the sentences are short, there's plenty of pausing, there's lots of to and fro. So you see a lot of design problems in sort of chatbots where you get these 30-word sentences, which would be impossible for a human to understand by hearing. Now, nearly done. So I'm just going to move on very, very quickly to what we're doing. I am co-founder of a company called Below Horizon. We, of course, we managed to start up a company just before COVID with Chinese investors. So you can imagine how well that's going. But we also managed to have a language learning company with a grammatical error in the name because it should be Below the Horizon, but there we go. So all very well. But what we do is we build systems for language learning, but generally for education, where the system itself is a dialogue system and everything else is embedded. And this is, I think it's a good way to go. But I do think you need the sophistication maybe of something closer to a fully fledged dialogue system than a normal chatbot, as it were. So the main thing is, because of COVID and for other reasons, we've started a not-for-profit. I spent a lot of time in refugee language and language education a long time ago. And so we've set up listenhere.ie, which is an NGO where we're using the technology from Mila, from the company, to create lessons for migrants based on life in Ireland. And what we need are, well, obviously money, but that's beside the point. What we need are people who are willing to talk to us for a minute or so. All Irish accents welcome, all fields of interest welcome. You can talk about your job, your sport, whatever you like. And then we use that as the basis for a lesson, where that's the text the lesson is built around, but the system itself can chat to the user, etc. So that's kind of all I really have to say. And I think I'm still within a half an hour, but I'm probably wrong. Anyway, thanks very much. And I'm delighted to take any questions. Thank you.